in 8.3, which is solving right triangles, you'll need a calculator because we're going to be calculating angles based on ratios. So have a calculator ready, take notes, and do the check it outs.
Our learning target today is I can use trigonometric ratios to find angle measures in right triangles and to solve real-world problems. All of the problems.
All right. The steepness of a road is often expressed as a percent grade. So 7.2% grade, it has to do with how fast it's going up versus how fast it's going across or rise over run. Yeah, there you go. So San Francisco is famous for its steep streets. Filbert Street is the steepest street. It has, wow, 31.5% grade, which means 31.5 feet over a horizontal distance of 100 feet, which is equivalent to a 17.5 degree angle. And if you are in a car, you would
notice
that's a pretty steep grade. We can use Trig ratios to change a grade to an angle. Isn't that exciting? And that's what we're going to do.
Fantastic. So here's our first example. Use the given trig ratio to determine which angle of the triangle is angle A. So here's our trig ratio. Cosine of angle A equals 24 over 25. So we have to set up the ratios here. So we have angle 1 and angle 2. So we have to see which one is going to give us 24 over 25. So in order to determine which angle, angle 1 or angle 2, we can take the cosine of angle 1, which is adjacent over hypotenuse. So we get 1.4 over 5. Then we want to get a common denominator of 25, so multiply top and bottom by 5, which will be 7 over 25. So angle 1 is not that. Actually, let's get rid of the check mark. It doesn't work. So now we look at cosine of angle 2, which would be adjacent is 4.8 over 5. Again, multiply the numerator and denominator by 5. And we're going to get 24 over 25. So angle 2 meets this. Is what angle A is going to be.
Okay. So here's one for you to try. Use the given trig ratio to tell which of the angles is A. So the sine of A is 8/17. So you're going to figure out which one based on this ratio angle A is. And then this is a second problem if the tangent of A is 1.875. So they're two different problems. They may or may not be the same angle.
So now we're looking at inverse trig functions. Up to this point, we've been finding the side lengths where we have sine of measure of an angle, or cosine measure of an angle, or tan measure of an angle. Gives us our side lengths. To find the angle measures, we'll use our inverse trig functions, which is on your keys. It's the second functions generally right above your sine, cosine, and tangent functions or keys. You have sine to the -1, cosine to the -1, or tangent to the -1. Set up your ratio, so instead of x, your ratio here, you plug that in here, and that's going to give you your angle measure. So these are going to be, using the inverse trig, you find angle measures. Pretty cool.
All right, use your calculator to find each angle measure to the nearest degree. So I'm going to plug these into my calculator, my handy-dandy calculator. I'm going to make sure that I'm in degree mode, and I'm going to get the following answers. So inverse cosine, that's what the little -1 means, inverse. And remember, it's kind of like the converse. So cosine gives you an angle, cosine of an angle gives you a ratio of sides. Inverse cosine of a ratio of sides gives you an angle. So inverse cosine, or inverse function, trig functions always give you angles. So if I plug this into my calculator and they want it to the nearest degree, I'm going to get 29.54, and the nearest degree then is going to be 30 degrees because I'm rounding up because of the 5. Inverse sine of 0.85 is going to give me 58.2. And to round to the nearest degree is going to be 58 degrees. And lastly, inverse tangent of 0.71 is going to give me 35.37. Rounding to the nearest degree, I get 35 degrees.
And so now it's your turn. You've got inverse tan, inverse cosine, inverse sine for these three. Good luck, and again, use your calculator, round to the nearest degree.
Right, find the unknown measures. Round lengths to the nearest hundredth and angle measures to the nearest degree. So we've got several unknown measures that we need to find. We need to find these two angles, and we need to find this side. So we're going to use both our regular trig function, potentially, you don't have to, and our inverse trig functions to find our angles and our side. All right, so to find angle T, I used my inverse function, and I had side length, this side length, which is my hypotenuse across from my right angle, and this side length, which is opposite to angle T. So the trig function that uses opposite and hypotenuse is going to be sine. So I do inverse sine of opposite over hypotenuse and get 29 degrees. And then to find my last angle R, I know this is 90 degrees, angle S, so the other two are 90, so our angle R is going to be 90 minus 29, which is 61 degrees. I could have used a trig function to find this missing side, but since it's a right triangle, I just used Pythagorean theorem. So x squared plus 5 squared is going to be 5.7 squared. That x is going to be the square root of 7.49, or about 2.74.
Yeah, you could have also found angle R first using the cosine instead of angle T first. So either one, but once you find two of the angles, you know the third one is going to be 90 minus the other acute angle.
So there are multiple ways to do these problems, which is nice, but it's also maybe a little more confusing. So just be careful.
So now it's your turn. You need to find the length of the hypotenuse and one of the legs. And then you have just one angle to find. Just this little guy here. I don't know what that angle measure is. Good luck. Yes.
Continuing on, a highway sign warns that the section of road ahead has a 7% grade. To the nearest degree, what angle does the road make with the horizontal line?
Ooh, draw a picture, draw a picture.
Yes, so I will draw a picture. So 7% means I'm going to be going up 7 and over 100. So if this is 7 and this is 100, and I know it doesn't really look like it's okay, so my rise is actually here, as Miss Aiken was pointing out, not over here. But the angle is right here. I can find that. How are we going to find it? Well, it's going to be an inverse trig function. So with respect to this angle, this is going to be my, I'll use a different color. This is my adjacent, and this is my opposite. So I know that tangent uses my opposite and adjacent. That's going to be opposite over adjacent. So it's going to be inverse tangent of my opposite over my adjacent, and that ends up being 4 degrees if you put that in your calculator. So whenever you look for an angle,
inverse functions.
Angle, that's not how you spell angle.
It's close.
Use an inverse. If you can remember that, it's going to make your life easier. Okay.
Okay, so here's your check it out. We have Baldwin Street in Dunedin, New Zealand. Has a 38% grade, much steeper than last one we looked at. So again, 38% grade means it's 38 over 100. It's in percent, so this is a rise over run. So for every 38 feet it goes up, it has horizontally moved 100 feet.
Okay, don't forget inverse function. All right, so that's the end of the lesson. What did we learn? Sine and cosine ratios never have a value greater than 1. Did we learn that?
That's kind of a repeat from prior. Yeah.
But we did learn inverse of sine is the angle whose sine is equal to x. The inverse cosine of x is the angle whose cosine is equal to x, and the inverse of tangent, the inverse tangent of x is the angle whose tangent is equal to x. This is how you find them in your calculators. You're going to get angles back. Make sure you're in degree mode.
Yes.
Good luck.
Have fun.